Namaste everyone. Welcome to class 11, chapter 3, trigonometric functions. In our previous modules, we learnt about domain and range of trigonometric functions and their behavior in different quadrants. In this module, we shall cover graphs of trigonometric functions and few examples. Let us recall behavior of trigonometric functions. As you must have seen, sine, the behavior of sine function, cos, tangent, cot, secant and cosecant in different quadrants. We shall move further. Now, specifically for sine, if we draw a graph according to this, see here, this is a real number line. This is the vertical axis where we plot till 1 and minimum value till -1, because we know the range of sin x is from -1 to 1, and at different angles at pi by 2, at pi, at 3 pi by 2 and at 2 pi. And here it is negative direction, same follows. Now, since in the first quadrant, that is from 0 to pi by 2, the value of sine increases from 0 to 1. See here, from 0 to 1 it increases like this, and in the second quadrant, that is from pi by 2 to pi, the value of sine decreases from 1 to 0. It goes like this, and it further decreases in the third quadrant, that is from pi to 3 pi by 2 till -1. So, here till -1 this will decrease in this third quadrant. If we move to further fourth quadrant, the value of sine increases from -1 to 0 like this. So, this is the graph of sine in one complete revolution, that is from 0 to 2 pi, and it keeps on repeating, since you know the value of sine does not change in integral multiples of phi. So, it goes on endlessly in that positive direction. You see it in the negative direction also, it moves in the same shape. So, this is the graph of sin x, as you can see. Now, we move to graph of cos function. Now, in the cos, the same way real number line, since cos is defined on for all real numbers. This is a y axis, maximum value 1, minimum value -1, and if we take pi by 2, pi, 3 pi by 2 and 2 pi, and similarly we can extend it further. Here in the negative direction, we take values of minus pi by 2, pi, minus 3 pi by 2 and minus 2 pi. Here in the first quadrant, that is from 0 to pi by 2, the value of cos decreases from 1 to 0, and it further decreases from 0 to -1, and from in the third quadrant, that is from pi to 3 pi by 2, it increases from -1, increasing graph, and then it further increases, and this is the graph of cos function in 0 to 2 pi, and this will also keep on repeating like this in the positive direction. So, in the negative direction also. As you can see, this is the graph of cos function. Now, we shall move to graph of tangent. Now, for tangent, see here. Here we know in the domain of tangent x, tangent is not defined at odd multiples of pi by 2. So, for that we need to first demarcate those points where tangent is not defined. Tangent is not defined at pi by 2 and 3 pi by 2. We will first mark these points means graph will not touch these points. Now, in the first quadrant, that is from 0 to pi by 2, tangent increases from 0 to infinity. It goes like this, but it will never touch this point pi by 2 because it is not defined at pi by 2. Now, in the second quadrant, that is from pi by 2 to pi, its value increases from minus infinity to 0. It is coming from this, from minus infinity to 0, like this. And in the third quadrant, that is from pi to 3 pi by 2, our graph is increasing from 0 to infinity. 0 to infinity it is increasing like this. Now, in the fourth quadrant, the value of tangent will increase from minus infinity to 0 like this, and it will go further, and at 5 pi by 2 it is again not defined. So, it will not touch this line. So, similar fashion we can extend this graph in the negative direction. As you can see, this is the graph of tangent function. Now, we come to graph of cot function. Again, cot is here cos x upon sin x. Therefore, sin x should not be equal to 0. Here our domain of cot x is all real numbers except integral multiples of pi. So, whatever values our function is not defined, we need to mark those points. Like in the previous graph, we demarcated integral multiple of odd multiple of pi by 2. Here we will demarcate these points pi, 2 pi. Here our cot function is not defined. So, in the first quadrant, it decreases from infinity to 0. In the first quadrant means from 0 to pi by 2, it is coming from this place infinity to 0, and in the second quadrant from pi by 2 to pi, it decreases from 0 to infinity, and in the third quadrant it again decreases from infinity to 0, same pattern goes like this, and in the fourth quadrant, that is from 3 pi by 2 to pi by 2, it goes from 0 to minus infinity. Though graph of tangent and cot appear similar, but they are just opposite, and you can see from the graph in the negative direction also. See here. Now, we come to the graph of cosec function, secant function. Yes, secant function, which is reciprocal of cos function. Cos should not be equal to 0, and cos is 0 at odd multiples of pi by 2. Therefore, domain of secant x will be all real numbers except odd multiples of pi by 2. Here also we will demarcate these points that we are not supposed to take values at these points, because here function secant function is not defined. Moreover, here the range of secant is more than 1 and less than minus 1. So, we need to take care. Here the graph in the first quadrant, it increases from 1 to infinity. It goes further from 1 to infinity, means this will be like this. And in second quadrant, it increases from minus infinity to minus 1. Now, from minus infinity to minus 1 like this. And in the third quadrant, it decreases from minus 1 to minus infinity. Minus 1 to again minus infinity, it decreases like this, and in the fourth quadrant the value of sec x decreases from infinity to 1. Decreases from infinity to 1. Here 1, we will come till 1 only. So, this is the graph of secant function that you can see here. If we extend it further in the negative direction, this will be like this, the similar pattern. Now, for cosec x, if we draw the graph, as you know, cosec x is 1 upon sin x, and for the cosec x to be defined, sin x should not be equal to 0, and for sin x not equal to 0, x should not be integral multiple of pi. If we draw this graph, so we will demarcate these points, integral multiple of pi, by these dotted lines, and here it is 1 and minus 1, because range of cosec x is more than equal to 1 or less than equal to minus 1. So, in the first quadrant, cosec x decreases from infinity to 1. It is coming from infinity and it will end up at 1. And in the second quadrant, that is from pi by 2 to pi, it will increase from 1 to infinity. Further, it goes like this. In the third quadrant, it increases from minus infinity to minus 1. Minus infinity here and minus 1, it will come till this point in the third quadrant, which is from this place to this place. In the fourth quadrant, the value of cosec x will decrease from minus 1 to minus 1. Here it was minus 1, decrease to minus infinity. So, this is the graph for cosec x, and these were graphs of all 6 trigonometric functions that we have studied. Now, we shall be doing few examples to make the concept more clear. Now, example cos x, it is given cos x is equal to minus 3 by 5 x, where x lies in the third quadrant. Find the values of other 5 trigonometric functions. From cos x, we can easily find out the value of sec x. Because sec x is reciprocal of cos x, it will be minus 5 by 3. And when we know the value of sec x, we can find the value of tangent x, because we know that 1 plus tangent square x is equal to sec square x. And we know, here we know the value of sec, we can find out tangent. So, tangent square x is equal to sec square x minus 1, sec is minus 5 by 3 minus 1, that is 25 upon 9 minus 1, which is your 16 upon 9. This is tangent square x. So, tangent x is root 16 by 9, which is 4 by 3, plus minus 4 by 3. Now, we need to decide whether tangent x is plus 4 by 3 or minus 4 by 3. Since it says, the question says it is in the third quadrant and tangent is positive in the third quadrant. Therefore, we will take the value of tangent x as plus 4 by 3 and minus will be ignored. Now, we have the value cos x, tangent x and secant x. With the help of tangent, we can find out cot x. Cot x is reciprocal of tangent, 3 by 4. And now we know cot, and since we know cot, we can find 1 plus cot square x is equal to cosec square x. Substituting the value of cot, we can find cos x. 1 plus 3 by 4 square is equal to cosec square x, which is 1 plus 9 by 16 equal to cosec square x, and this will be 25 upon 16 cosec square x, and cosec x will be equal to square root 25 by 16. Solving this, it will give us plus minus 5 by 4. Again, we need to decide whether to take value of cos x as plus 5 by 4 or minus 5 by 4. Cos x is reciprocal of sin x, and sin x is in the third quadrant is negative. Therefore, cos x is also negative, that is minus 5 by 4. Now, in this example, we have been given the value of cot x, that is equal to minus 5 by 12, and x lies in the second quadrant, and we have to find the values of other trigonometric function, same as the previous example. If cot x is given, we can find out tangent x as reciprocal of this, and applying the relation of 1 plus tangent square x equal to secant square x, we can find the value of secant x, the same fashion as we did in the previous example. Now, since x lies in the second quadrant, we need to decide whether secant is positive or negative. In the second quadrant, secant, which is opposite of reciprocal of cos, and cos is negative in the second quadrant. Therefore, for secant also we have taken negative sign, and we will ignore the positive value. And this also, when we know the secant, reciprocal of secant will give us cos, that is minus 5 by 13. And applying the value of tangent x and cos x, finding product of this, we will get value of sin x, which is 12 upon 13, and cos x is reciprocal of sin x. Therefore, the value of here cos x is 13 by 12. Now, we move to another example. Now, we need to find the value of sin 31 pi by 3. Now, you as already know that integral multiple of 2 pi, the value of sin or cos does not change. So, how to convert this in terms of one complete revolution? We will divide 31 by pi, which is our improper fraction, into mixed fraction. 31 divided by 3, it will come like this. So, we can write this as 10:1 by 3, where 10 is the whole part and 1 by 3 is the fractional part. We can break it into sin 31 pi by 3 can be broken into sin 10 pi plus 1 by 3 pi, where it will not make any change in the value of sin. Therefore, we can jump to simply this, so sin pi by 3, and sin pi by 3 you already know is under root 3 by 2. So, this was the solution of this example. Now, we move to our last example. Find the value of cos minus 1710 degrees. Now, it is in degrees. When it is in degrees, we need to convert it into multiples of 360 degree instead of 2 pi, multiple of 360 degree, which is the next multiple of 360 degree. 360 multiplied by 5 will give us here 1800 degree. So, if we add 1800 to this angle, it will not make any change. Cos minus 171 degree plus, if added 1800, that is 1800, which is multiple of 360, it will not affect its value, but it will help us to make this negative value positive, which is cos 90 degree. If we subtract 1710 from 1800, it will give us cos 90, and cos 90, as you all know, is 0 degree. This is the solution of this problem. So, this was end of module 4. In our next module, we shall cover trigonometric identities based on sum and difference of two angles and their derivations and examples based on these identities. Till then, thank you.